This topic in Chapter 1 is called Absolute Value Equations and Inequalities. So absolute value, I think most times you hear about it, you hear it discussed as a distance from the origin. Does that make sense? So if A is the coordinate of a point on a real number line, then the distance from the origin to A is represented by the absolute value of A. So how many steps you are away from 0, and it's called the absolute value. Okay, and just a couple of quick ones, like if I gave you the absolute value of 6, how many spaces from 0 is 6? 6. How many spaces from 0 is -6? Also 6. And you learn this in elementary school, and you're like, oh my gosh, the absolute value just takes the negative signs away, right? And it does so in a very specific way. It does it, so when you have a positive number, the absolute value is just itself, right? But when you have a negative number, is it clear that another way to make that negative go away is to do a double negative? Does that make sense? Okay, has anybody ever seen the picture of the absolute value function in a class before? Like the graph of it? What does it look like? It looks like a V. Okay, so here is another definition of the exact same thing. So this is called a piecewise function. And what that means is you have two distinct pieces that behave in different ways. Like in that V picture, if you haven't seen that, it's okay. We'll talk about where that graph comes from. Do you see how you have this side of it where it goes up and this side where it goes down, those two distinct pieces? So think the bottom piece is the easiest one. If x is bigger than 0, that means x is positive, right? Does that make sense? So what that says is to find the absolute value of x, if your x is positive, it's just itself, okay? Now the second one says that if x is less than 0, what does that mean about x? Is it positive or negative? Negative. So if x is negative, you negate it. So what freaks students out is they're like, oh my gosh, that thing has a negative sign there. What the heck? They told me in elementary school that there were no negatives as absolute values, right? So why is that okay? Why does this negative sign actually result in a positive once you plug your x in?
Is there actually a negative anyway? So negative times negative is positive.
Yeah, this x number, as it is, has a negative built into it. The only x's that get plugged into this part are things like -5, -7, -10. And then you do negative, -5, negative 10. That's why. And that lets you find trickier absolute values like the ones that we're going to do in part B and C of the next problem, okay? So, for example, okay, so -7, easy enough, but using that definition above, would you plug -7 into the top thing or into the bottom thing? Top thing. So that would be equal to -7, which is 7. And they're like, that's so silly, it just makes it positive. But all right, now it's a little bit weird when you have something like pi minus 3. Does this just become pi plus 3?
No.
No, that's wrong. Okay. All right, now think about pi minus 3 as a number. Approximately what is pi? 3.14. So pi minus 3 is about equal to 3.14 minus 3, right? Which is about 0.14, right? The point is this pi minus 3 a positive or negative number? Positive. So the absolute value of a positive number is just the same thing. So that just equals pi minus 3. Okay. All right, how about 3 minus pi? So if pi minus 3 is positive, 3 minus pi is negative. So when you have a negative number, how do you absolute value it? Times by -1. So this becomes negative 3 minus pi, which is the same thing as
-3 plus pi.
-3 plus pi or pi minus 3. It's the same thing, same answer as part B. You can also, when you're doing a problem like this, if you want to check, did I get it in the right order, you could, round pi and approximate it. The reason you have to do this sort of like subtracting before you absolute value is order of operations. It's like the absolute value is like parentheses. You do the stuff in the parentheses first. Okay, so that's tricky thing with absolute values. Now, so does it make sense that changing the order of subtraction inside an absolute value isn't going to change the answer? I think if you change the order with subtraction, all that happens is the signs of your answers change. Does that make sense? Like if you do 5 minus 2, that makes 3, which absolute value is to 3, right? If you do 2 minus 5, that makes negative 3, absolute value is to 3, right? So within absolute value bars, you can change the order of subtraction. And that should make sense distances. So the distance between 2 points on a number line is either given by the absolute value of b minus a or a minus b. And the point is those are the same thing. And it's called the length of the line segment joining a and b. So if you wanted to find out how far apart 100, we'll say a is equal to 100 and b was equal to -7, how far apart those were, you could do the absolute value of 100 minus -7. And how many units apart would those two things be? 107. So that's all that's saying. The main thing we're going to do today is solve some equations that have absolute values in them, and also some inequalities. So here are the really simple ones first. These you should be able to do kind of by seeing and checking. So the absolute value of x equals 5. So think about equations as answers to equations are numbers that when you plug them in, they work out, right? So what is one number that you can plug into that equation that works out? 5. X equals 5. Is there another number whose absolute value is 5? -5. Notice that there were two answers, right? Okay. Now the next one, so also you can think about that as saying, okay, we want the numbers who are a distance of 5 from 0. And there are two numbers that are distance of 5 from 0. One's +5, one's -5, right? Okay. Now the next one says the absolute value of x is less than 5. So inequalities, let's draw a number line and just think about what points work. So 5 is kind of a boundary. If I plug 5 in, does it work? Yes, okay, it does. It's on the borderline, but it does. How about something like 6? Does 6 work?
No.
Nope, okay. How about 4?
Yes.
Yes. Okay, how about 3? 2. 1. 0. Okay, so all the way down to 0, we know all those numbers work. Now how about the negatives? Would -5 work? Okay, so -5 works. How about numbers bigger than -5, like -4?
Yes.
Yes, okay, so all those work. Does anything to the left of -5 work?
No.
Does it make sense that -6, when you plug that into the inequality, doesn't work? Okay, so now look at that picture. Write that as an inequality, one of those between ones, with no absolute value bars. So what's the lowest number? -5. Less than or equal to x, less than or equal to 5. So if you want to get rid of the absolute value bars for this kind of inequality, it's equivalent to that. It's the same thing. Okay, and also you can think those are all the numbers who are a distance of less than 5 away from 0. I think the geometry helps a little bit. Now this other one, absolute value of x is bigger than 5, so all the numbers that are more than 5 away from 0. So does 5 work? Yes. Okay, how about 4? No, how about 6?
Yes.
7? 1,000?
Yes.
Yes, okay, so 5 on up. -5 also works, right? The other numbers that work, are they on the left of -5 or are they on the right of -5? On the left. And that would be one of those things where you had to have a union. Does that make sense? Or an or? So you could say x is less than or equal to -5, or x is bigger than or equal to 5. Other than being a prime and the number of fingers you have on one hand, is 5 a special number? Not particularly, right? But like if this would have been a 7, what would have changed?
7.
These would be 7s. Does that make sense? What if this didn't have an equal to sign on it? Get rid of the equal signs, right? And the point is if you want to take absolute value bars off of an x, if you have an equation, it becomes 2 equations. And if you have an inequality, what kind of inequality it becomes depends upon the way that inequality alligator eats. Does that make sense? If the inequality alligator eats the 5, it's this one, right? If the inequality alligator eats the x, it's the other one. Another way that you can remember it, I think is a little bit helpful as well. Remember how dividing by a negative changes the sign of an inequality? Look at this one relative to the original. Do you see how the sign kind of flipped? And that comes from that negative x definition of absolute value. You divide by a negative and the inequality flips with the negative side. And if you cover up this 5, do you see how it also happened there? In the original one, the 5 was being eaten, right? In this half of it, the x is being eaten. Okay, so let's use those to, and also one thing is that this is one way that my Algebra 2 book was actually harder than your pre-calculus book, because they assume that that number is positive. My Algebra 2 book got tricky. They gave them something like absolute value of x equaled -7. How was my Algebra 2 book being tricky with that?
No solution.
That's no solution. You can't do it. Because the absolute value is always a positive number, right? And so it can never equal a negative number. Another way to think about these, if you know how to graph absolute values, an absolute value is a V scenario, right? How about like y equals 5? That's a horizontal line. They intersect 2 times. And so we can also talk about that once we know how to graph it. I think that that might even be a better way to solve these. But, okay, moving on. So properties of equations and inequalities involving absolute value of x. So for p is bigger than 0. So actually this depends. There would be no solution. And that actually depends on which situation. We could just say weirdness. I spelled that weird wrong. I spelled weird wrong, didn't I? That's embarrassing. We'll say strangeness. I can spell strange. Okay. So absolute value of x equals p. That's the same thing as x equals p or x equals negative p. What is the absolute value of x is less than p the same as? How would you make that an inequality without the bars?
Negative p is less than x.
Uh-huh.
Less than p.
Very good. Negative p is less than x, which is less than p. And x is greater than p. What's that the same thing as? Sorry.
P is greater than, no, is greater than x and p is less than x.
So I got x is greater than p.
Well, negative p.
No, I think it's definitely x is greater than p is one of them.
Oh, x is less than negative p.
X is less than negative p. There you go. If you listed them in the opposite order, that doesn't matter. Let's talk briefly about what would happen if p was negative in each situation, because it's actually a little bit different for each of them. So what if you had absolute value x equaled negative when we discussed that's no solution, right? What about absolute value of x less than -1. That also is no solution. The reason being a positive cannot be less than a negative, right? What if I made it absolute value of x bigger than -1? Is that also no solution?
No.
That's always true, right? So the solution for that is actually all real numbers. And if you were to graph it, you would get -infinity to infinity, meaning everything works. Another symbol for all real numbers is this R with 2 lines. So when I made that little blank, I sort of didn't think hard enough about the fact that what happens when you have a negative number is different based on which way the inequality points. And I don't think your book gets that tricky, but my Algebra 2 book did, and if those kids had to learn it, man, you should be able to do that too. You guys are all smarter than my Algebra 2 kids, right? Better be. Okay. Of course you are. All right, and I have a cheesy way to remember it. I think about the absolute value bars as being a prison. And you're stuck inside the bars because you're in a prison. And when you leave the prison, you have 2 choices. You can choose to be positive, or you can choose to be negative. Oh, that's like cheesy. So that's a little bit different than the previous thing we had, because the previous things were just x's, right? But just think about it as absolute value of some stuff. In order for this equation to be true, the stuff inside has to be 6, right? Or the stuff inside has to be -6. And this kind of setup will allow you to solve more complicated ones that you can't do in your head. Because I understand that you can kind of guess and check this first one in your head, right? You can think, what number plus 2 makes 6, right? And so what number is that? 4. So one answer is x equals 4. Is the other answer just guessing? Is the other answer -4? No, because -4 plus 2 will make -2 and not 6. So what is the other answer? It'll be x equals -8. So the numbers that you get for answers of these equations won't always be opposites. Okay? All right. So how about this one? Is this one more like, looking back at the page before, is it more like the second one or more like the third one? Is it more like absolute value of x is less than p? Is it more like absolute value of x is greater than p? Which one is it more similar to? The first one. And that first one translated it to x was between -p and +p, right? So how will that work for this one that we have in part B? Plug in the same numbers, and who's going to be stuck in the middle? X plus 2.
Yeah.
Does that make sense? So this is the same thing as -6 is less than x plus 2, which is less than 6. The numbers you're going to get as endpoints will be the same numbers as part A. Yep. Then you solve that inequality. Okay, so what do? Take away 2 in 3 places, and what's your final answer? Exactly. Beautiful. And that one, to check and see if you're right, you could pick like a random number between those 2 things, and you could see if it worked. Yeah?
Why can't you do the same method that you used in the last one when you make 2 equations?
Oh, you can.
The same answer.
Yeah, so another way that this is actually taught is to have one equation that is x plus 2 is less than 6, and then you also have to have that x plus 2 is bigger than -6. And that also works. You get x is bigger than, wrong, x is less than 4, and you get that x is bigger than -8, and then put them together as 1, and you get the same answer. So that also works.
So you are supposed to put them together as 1?
You are supposed to put them together as 1 for stuff like this, and the sort of implied thing when you put them together as 1 is it does matter if you have and versus or. And the tricky thing about that is this particular one implies an and, whereas the next one implies an or. So that's a great question, but that one definitely is sort of, this notation that I use on the top is a way to write 2 inequalities as 1. So it kind of does two equations by default. But if you like this way better, because it helps you think, okay, because I have an absolute value, I need two of them, that's also fine, as long as you can put the answer as one. You guys are so good. Okay. All right, let's look at part C, or not, why did I say part C? Part A of example 4. So how is part A just a little bit different?
X can't equal -2.
Yeah, the thing that's a little bit different is I have this whole bigger than 0. And absolute values, like if I write down this, absolute value of x plus 2 is less than 6, that kind of has a less than or equal to 0 in it. Does that make sense? Because this expression, it's never going to go negative, right? But it could go down to 0, and that's okay. So this expression in part A is the exact same as the previous part B, except for you have to leave out the number that makes x plus 2 equal 0. So what number would that be?
-2.
Yeah, x cannot equal -2.
So couldn't we find that by just solving like the middle?
Yes, that's exactly how you find it. So because you're looking for what makes the middle 0, right? And like this is the thing, if you're a little careful about when you say solving the middle, you've got to say solving the middle equals what, right? Because it could be that you're solving the middle equals 1 or 10 or whatever, but specifically it's looking for what makes the middle 0. That definitely is the pattern. Does that make, it'll always be if you've got x plus a number, it's always the opposite of that number that's added, right? But yeah, and that's kind of what I wrote down is effectively solving the middle equal to 0, isn't it?
And we're making it equal, well, like, for example, you could just drop that, well, not drop the absolute value bars, but you remove them from there, then you subtract 2 from both sides, so it'll give you -2.
Oh, I see what you're saying. Yeah, the way to, yeah, that doesn't give you the entire picture.
Okay, so we need to make.
So what you need to kind of do, I was going to write those steps down, so you kind of need to solve x plus 2 less than 6 first, like we did in the previous problem. Okay, and then your second step is to leave out x equals -2. So here, let's draw the picture. I think it's a little helpful. So we have -8 up to, what do we have, 4? Okay, and open circles on either end. And then you just have to leave out -2 and have an open circle there as well. Pretend like my circle isn't filled in. Look, all of a sudden it's not going to be. There you go. And the point is the numbers between -8 and -2, they still work. Like think, does -5, when you plug it in, well, -5 plus 2 is -3, right? It's still absolute value, something that's less than 6. So that's the tricky thing about those. Those are more tricky than I think I'm probably going to put on your quiz. But it's just worth mentioning that you have to leave out just that one number. Yeah.
Where'd you get the -8 from again?
I got the -8 from part B of example 3.
Oh,
Does that make sense? So in the one above, like I said, you're solving this first, right? And that gives us the -8 to 4. And you just can't be equal to 0, so you've got to leave out that one place where it equals 0. Now, what would that be as an interval?
It'll be all open brackets.
Uh-huh.
-8, -2, union -2, 4.
Exactly. But what's most important to recognize in that kind of problem, are sort of like these two steps that I wrote down, is that it's kind of the same thing as ignoring the 0 and solving that inequality first, and then leaving out that one place where you equal 0. But that's the most tricky it's going to be. How about part B? Why is part B in example 4 different than part B in example 3? What's different?
X plus 2 is greater than 6.
Yeah, so the inequality goes the opposite way, right? So in this one, you're solving x plus 2 is bigger than 6, or what other one?
X plus 2 is greater than -6.
Almost less than -6. Remember, the one that has the negative is the one where the inequality is flipped. Okay, and so the first one is x is bigger than 4, right? Or x is less than -8. And I'm pretty sure you're going to have to give your answers in both inequality notation and interval notation. Like, I want both of them on the quiz. So let's just graph that to, I think that makes it easiest to translate it into the other notation. So do we have open or closed circles at +4 and -8? Opens, yep, so open at -8, open at +4. Which way does the arrow go at 4?
Goes to the right.
Goes the right. Which way does the arrow go at -8?
Left.
Left. So can you write that as one interval, or will you need a union symbol? You're going to need a union symbol. Does that make sense? To join the two together. So your first interval is -∞, -8, union, what's the second one?
4.
4 to infinity. Those, I think, were pretty easy, and you can probably solve them without actually having to do too much algebra. You can just like kind of guess and check in your head. But if you have a more complicated expression inside your absolute value bars, these are the same properties that we had restated, just with ax plus b instead of x inside. Does that make sense? So the other ones that we had were like absolute value of x equals p, right? And that was like, okay, well, x is positive p or x is negative p, right? This time, that ax plus b is kind of like your x. So when you're solving an equation like this, you either solve ax plus b equals p, that gives you one answer, or you solve ax plus b equals what other number? Negative p. We did that in example A of part 3. Does that make sense? It was just 1x plus 2. What is the second one going to be equivalent to without absolute value bars? Ax plus b is less than p, yep.
Or ax plus b is greater than -p.
It would be but you got the right idea. That's the one that's between. But you could think if I'm a distance of p away from something, I'm p above or I'm p below. Does that make sense? So either p above, that's positive p, p below is negative p. Now the next one is ax plus b is bigger than p. Or, what's the other one?
Ax plus b is less than -p.
Yep, ax plus b is less than negative p. All right. And so what we're going to do next is we're going to solve some more complicated ones. Now, one thing I want to say about this before we move on is that before you get your absolute value bars and take them away, you have to have them all by themselves. So what I mean is there must be no numbers added to an absolute value. We'll have an example. We've got to actually move a number away before we break it up. All right, so is this one going to be an inequality, or is it just going to have two answers? Just going to have two answers, right? So one equation you solve is 2x minus 1 equals 8. What's the other equation you solve? equals negative 8, exactly, yep. And what that's doing is you're saying, okay, in order for this to work, the 2x minus 1 has to work out to 8, or it has to work out to negative 8. And once you get that, the remaining stuff is super easy, right? So the first one, you got 2x equals 9, right? And x is equal to 9/2, yep. We're gonna practice using improper fractions, woohoo! And the other one, what happens when you add 1 to both sides? What do you get?
-7.
-7, great. And your answer on that one is -7/2. And notice that they're not exact opposites, right? Okay. So the next one, before you break up, there's a slight problem. What is the slight problem?
-1.
Yeah, that -1 there. So the whole breaking it up property won't work unless you have the absolute value bars all by themselves first. So first you have to take that 1 and add it to the 3, okay? I noticed that Alex has questions like this and your textbook didn't. So just be aware that that's there. So the absolute value of 3x plus 5 is equal to 4. And if you wanted to prove to yourself that the other way didn't work, you could try it and then check your answers. One of them will work and one of them is going to be wrong. And now that you've made it like this, what 2 equations does it break into?
3x plus 5 equals 4, and 3x plus 5 equals 9.
Great, 3x plus 5 is 4, or 3x plus 5 equals -4. Okay, so that will be 3x equals, very good, and x is -1/3, great. This next one, you take away 5, you get 3x equals -9. Divide by 3 and you get x equals -3. So there's your 2 answers. Your book might list it this way. They might say curly bracey thing, -1/3, 3. So the curly bracey things mean that you have a list versus an interval. Does that make sense? If you write down -1/3 and -3 in parentheses, that means an interval. Does that make sense? So I really prefer to write x equals blah, x equals blah, but the book's notation might be that way, or Alex might be wanting you to put it that way. Does that also make sense? So it's just a way to give a symbol that says this is a list, that's all. I can't draw those braces to save my life, so I try to avoid it. Do you know what I mean? They're really hard to draw, aren't they? Okay, maybe you're more talented than I am. Now this one. So you gotta figure out, is this one of the between ones, or is it one of the or ones? That's what you're gonna be able to tell.
It's an or.
It's an or, because of the way the inequality points, right? So one option is 4x minus 3 is bigger than or equal to 5, or 4x minus 3 is less than or equal to -5. You can think if I'm a distance of more than 5, I'm either bigger than 5 or I'm less than -5. And I am 4x minus 3. That's who I am. My life must be boring being a line. All right, so add the 3. You get 4x is greater than or equal to 8. Great. Oh, it rhymed. X is bigger than or equal to, sorry. I think 2.
2.
It's okay, we all have our moments. All right, next one, we get 4x is less than or equal to, Then you divide by 4 and you get x is less than or equal to -1/2. Spectacular. So that's your interval notation, or that's your inequality notation. Okay, whoa. Empty the garbage, it's so noisy. So from 2 on up, -1/2 on down. Those intervals, those lines do not overlap, do they? Okay. So what would that be in interval notation? What's the first part? Ignore the dump truck outside. It's very hard.
Open bracket, negative infinity to negative 1/2, close bracket.
Very good.
Close bracket 2 to infinity.
Great. Remember, those infinities always get open parentheses because you can never get all the way there. Okay, sorry. I'm so distracted by this. All right, the next one, how a little bit different.
There's not the equals.
There's not the equals, and also the inequality goes the other direction, doesn't it? So when you take away the bars, you have to make this into 6 minus 5x. That's smaller than 16, but it's bigger than negative 16. And the whole point is you took this problem and reduced it to something that you can actually do. So now take away 6 in all three places. So that's, what's negative 16 minus 6? Great. It's less than negative 5x, which is less than 10. Great. Now what happens when you divide by negative 5?
They all switch.
They all switch. And also a negative over a negative makes a, so 22/5 is bigger than x, which is bigger than negative 2. Probably best to write that like this, negative 2 less than x less than 22/5. Do you think they realize how noisy they are? Probably, they just don't care. So as a graph, what would that look like? What happens at negative 2? Open circle. What happens at 22/5? Open circle. 22/5 is just over 4. Does that make sense? It's 4 and 2/5, which is actually 4.4. So what would that be as an interval notation? Parenthesis or bracket on the negative 2? Parenthesis. And how about on the 22/5? Also parenthesis. So the trickiest thing with these is just remembering that you have to do sort of two inequalities, right? And the inequalities are tricky because you remember which one is it? Is it the between or is it the ors? Yeah.
It's always the same, like if it's chomping to the left, then it's or, if it's chomping to the right, it's and.
But what matters with the chomping is how it chomps relative to the absolute value bars.
Okay.
Does that make sense? Because I could have written this one like this. And it still should produce the same thing. Does that make sense?
Okay,
So your rule is true if you write the absolute value bars first and then go from there. Does that make sense?
Okay, yeah, so otherwise, like if it's chomping away from the absolute value bars, it's and if it's chomping towards, it's or.
Exactly. The way that I remember it is to think about something that I can guess and check, like we did in the very first example with the 5. Does that make sense? That's how I think about how to do it personally. But you might be different. All right, now some key stuff. So far we've solved absolute value of something equals a number, not absolute value of something equals something else that has x's in it, right? Now these are a little bit funny because these sometimes have 2 answers, they sometimes have 1, and they sometimes have none. And unless you graph them, there's no great and easy way to tell. So here's the deal. Do you guys know that this thing, if you graph it, it makes a V-type shape? And let's have 4 thirds. So something like this. This thing is a line of some sorts, right? And so the question is does that line intersect the V? You can see you could intersect it twice, right? What if my line had begun like way the heck down here and went like that? They'd never intersect, right? Or you could do something like this where they'd only intersect at one point. Does that make sense? And the only way at this level to see that if you're right or wrong is to solve the equation and actually check the answers. So when you see absolute value of something equals x's, you have to tell yourself that you are going to have to check. I mean, theoretically speaking, checking all your answers is a really, really good idea. It's just that it's so tedious and I make you do so much other work. I don't want to like make you check too, because something else that happens is you check it and then you check wrong and you think that you're wrong when you're not. Has that ever happened to anybody?
Yeah.
Like you check your answer and you're like, oh my gosh, I'm wrong. But your checking was wrong, not your answer. Does that make sense? Okay. But on these, you absolutely positively have to check. You've got to know that. Otherwise, the process is very similar. You solve one equation, that's 3x minus 4 equals x plus 5. And you solve another equation, that's 3x minus 4. Here's the one tricky thing. It equals negative parenthesis x plus 5. So tricky thing number 1 is you must check. Tricky thing number 2 is you've got two equations. Tricky thing number 3 is the parentheses. Does that make sense? So to get the opposite of x plus 5, you must negate the whole thing. Multiply the whole thing by negative 1. So don't forget the parentheses. When in doubt, put them in. Okay, now other than that, once you know that, is solving these very difficult? No. So should we get the x's on the left in the first one? What do you think? Okay, so to do that, we would take away x. That gives us 2x minus 4 equals 5. And then what will we do next? Add 4. So 2x equals 9. And x is equal to 9 halves, or 4.5. I'm going to use that 4. I'm not going to actually, I shouldn't do that. I shouldn't box the x. I'm not positive that it's right. Okay. It's amazing that white functions as an eraser. Duh. Okay, so let's just go ahead and check it right away. When you check, you always check in the original. So let's see. What is, we're going to see, what is 3 times 4.5 minus 4? Does that equal 4.5 plus 5? Yes or no? So that's my little checking. Once I've checked it, I'll box it. So without a calculator, what is 3 times 4.5? 13.5. You could do 4 times 3 is 12, and then 3 times 0.5 is 1.5. What does the right side equal? 9.5. And what's 13.5 minus 4? Okay, so does the absolute value of 9.5, does that equal 9.5?
Yes.
Yes, okay, so that is a legitimate answer. We've checked it out. Great. Ooh, one solved, one to go. So this one is 3x minus 4 equals, what happens when that negative distributes? Negative x minus 5, very good. Okay, once again, let's put the x's on the left. So how would we get that negative x over to the 3x? Plus x, very good. So 4x minus 4 equals negative 5. Now we add 4. You get 4x equals negative 1, right? So your answer for x in that one is negative 1/4 or negative 0.25, right? I have a slight question about Alex. If your answer for something is like 1/3 and you give it 0.3, does it tell you you're wrong?
It should.
Has anybody, I know it should, has anybody encountered that before? Not yet? Okay. Why, if the answer is 1/3 and you give it 0.3, you're kind of a little bit wrong?
Because 0.3 is a repeating decimal.
Yeah, 0.3 is repeating yeah, so 0.3 is 3/10, right? Versus 1/3, which is 0.3 repeating forever, right? So in general, if your decimal ends, no big deal, right? But if it repeats, probably give it a fraction. Does that make sense? Okay. So let's check this one. I boxed it before, but it's gonna work. Okay, so let's check it. Alrighty. So we'll do 3 times negative 0.25. The equation was -4 equals negative 0.25 plus 5. So the right side's really, really easy. What's negative 1/4 plus 5? 4.75, yep. So you had $5 and somebody borrowed 1/4, right? All right, 3/4 is 0.75, so you got negative 0.75 minus 4. Can you see right there that that one actually does check out? Because in the bars you get negative 4.75. So in that case, they both work. Absolute value negative 4.75. That definitely equals 4.75, right? After you absolute value it. Okay, great. So how about you try example 8, because it's very much the same thing. It's actually even a little bit easier, and you'll get 2 whole number answers and check them. One of them is not going to work. Ready, set, try.
X does not equal.
Shush, just do the problem
I
without
did
saying.
it.
Did it already? Okay, well, sorry. Don't ruin the surprise. Did you guys get 6 and 1? Did you get that 6 worked and 1 didn't? Okay. Some textbooks call those numbers that don't work extraneous solutions or extra solutions. So, and there is, I'm not withholding a pattern from you. Like, it's not the case that if 1 doesn't work, it's always the one that came from the negative. Does that make sense? Like, I'm not purposely not telling you stuff. So it just, you just have to check. And you only have to check when you have absolute value of some stuff equals things with x's in it. So just think to yourself when you're doing your work, which ones do I actually have to check?
A good way to check is just to plug it in like really fast and like 6 plus
Yeah.
4 is a positive.
Yeah, versus the other one where 3 minus 8's a negative.
Yeah.
They're always gonna not work in a specific way. Does that also make sense? Like, I'm pretty sure that when you're checking, it's always gonna not work in the way that you have something positive equaling the same number but negative. Does that make sense? It's always gonna not work out like that because of the way that you solve this stuff. There are other situations in different types of equations that you're solving in which that will be the extraneous solutions are different, but that's, for this one, they'll all be like that. Okay, well, we might finish that last page. The last page is fast. You ready? Okay. So if x is positive or 0, then what is the square root of x squared? Yeah, it's just x. And I was going to explain this with a number. So for example, like, give me your favorite positive number.
19.
Okay, spectacular. Oh, how about I don't know 19 squared.
7.
7. Can we do 7 instead? Okay. So I meant, it's kind of like when people say, oh, what's your favorite food? Oh, not that. X is 7. Okay. So if we square root 7 squared, PEMDAS says first you square, right? So squaring the 7 makes 49, which then roots to 7. The point is that was the same number as what you put in, right? Now, what if the number you put in is negative? So what if your x equals negative 7? Then you have the square root of negative 7, the whole thing squared. So, yeah, so that is 49, right? Does that make sense? Which equals, was it the exact same number you put in?
No, it's absolute value.
Yep, or it's the opposite, right? It's negative x. Does that make sense? So the point is that a square root and a squared written in that order is the same thing as absolute value. So those, same thing. And I'm actually pretty positive that the order matters. Like, it's not okay to write root x squared. Why would that second one not be okay?
It's not simplified.
No, it's not that. So in the first one, can you plug in negatives?
Yes.
Yeah, you can, right? Because first you square them, which makes them positive so you can root them, right? Versus the second one, can you plug in negatives?
No.
Not without having something with eyes, right? So that's why they specifically write it this way, is because in the first expression you can plug in negatives, in the second one you can't. But the main point is it's the same thing as an absolute value. So if I say solve this, you're like, well, that's the same thing as absolute value, x minus 2 equals 5. No problem. Can you solve that? Yes. So what are the two equations you're solving? X minus 2 equals 5.
Negative 5.
Or x minus 2 equals negative 5. So that gives you x equals 7, spectacular, or x equals negative 3. Great. Part B is the same idea. What's the only difference? It's an inequality, right? Yep. So you're solving the absolute value of x plus 2 is bigger than 3. Is that going to be an or one or a between one? Or. Spectacular. X plus 2 is bigger than 3, or x plus 2 is less than negative 3. So the first one ends up being x is bigger than 1, or x is less than negative 5. And I'd like your inequalities in interval notation too, so let's just picture what that looks like. At 1 we have an open circle on up, right? Negative 5, open circle backwards. So that's negative infinity to parenthesis or a bracket. Parenthesis. And then 1 to positive infinity. I know the next two problems have words in them, but they're really not that bad. You shouldn't see words and freak out. You should see words and read. That's a better strategy. Okay. So in order to manufacture a polymer for soft drink containers, a chemical reaction must take place within 10 degrees Celsius of 200. So write this temperature restriction as an absolute value and then solve to find acceptable temperatures. Now, this is one of those questions in which making it the absolute value equation is trickier than making it into the interval, right? Because being within 10 degrees of 200 means you have to be within what?
190 to 210.
Exactly, so you're kind of like, okay, this is 190 to 210. So let's just talk about how would we figure out what that would be as an absolute value type thing. So is it temperature minus 10 is less than 200, or is it temperature minus 200 has to be less than 10? Which one of them did that come from? So here's the thing, the difference between your temperature and 200, so is that the first one or second one? I think it's the second one, right? Because your temperature and 200 differ by less than 10. So I am totally fine, because these are easy to figure out without them, as if you are able to give the interval just by using your brain. Does that make sense? And then try to think, okay, what inequality did that come from? Another place that happens is with measurements. Does it make sense that measurements are often not exactly exact? They're within a certain margin of error, right? So this volume is approximately equal to 6.94, and the error is less than 0.02. So what numbers would your volume be between? What is the lowest it could be? And what's the highest it could be? 6.96. And then what would the inequality be? Volume minus 6.94 has to be less than 0.02. And the absolute value barring allows you to account for the fact that you could be under or you could be over, right? All right, so that's it. Great, we're done. Thanks for being patient with me.